Hi, welcome to a nostalgic math chat. We are inside IEB paper 1 of November 2023, checking out question 6a. So, finance questions, I don't know, I haven't seen them get a lot of focus there by level 3, level 4. So they typically are just going to look like something you see in your textbook. So I thought now and again I will just then cover questions like, questions on topics like finance, even though they're not necessarily like, the kinds of questions that could throw you in for like a proper ringer. Just because, gotta cover topics. There are certain topics that I just have no desire whatsoever to cover, like data handling. So unless I get possessed by some other spirit, there's certain topics that you probably just won't see on this channel. And finance is probably also close to data handling, just in terms of my least favorite topics in maths. But yeah, the heavens have decided that we will have a finance question today. Also because it's like, it's one of those ones where the timeline is not so straightforward and, there are interesting things to consider. Anyway, done justifying why we're looking at question 6a today. We are looking at it. Right, let's see what information we're given. You invest into 2 different investment schemes for a period of 5 years. Investment number 1, you place 3,500 Rand into an investment at the end of each month. Interest on this investment is 15% per annum compounded monthly. Cool. Investment 2, you make a deposit of 24,000 Rand immediately and then only make a second deposit of 7,000 Rand into the same account at the end of the 3rd year. Interest on this investment is 20% per annum compounded quarterly. If you combine the value of your 2 investments at the end of the 5-year period, what is the value of this lump sum? Okay, cool. Give your answer correct to 2 decimal places. Okay, so I'm going to start by drawing the timeline for investment 1. Okay, so this is a timeline where, at T0, we just open the investment, but we don't we open it and say, create a debit order to start taking money at the end of this month and each month after that for 5 years. So at T1 is where we put in our first deposit, which is 3,500, and then T2 again we add another 3,500, and so it goes until at T60, because there's 60 months in 5 years, we put in the last 3,500 Rand. I mean, almost pointless at that point, but anyway, such is the question. So what is the value of this investment after 5 years? Okay, maybe this is another reason I've kind of avoided finance is I do not know those formulas to save my life. I just always look at the so situation like this where you keep putting in money. I just look at it as a geometric series where so at the end of T1 we'll have 3,500 Rand. This is interesting. Oh yes, okay. I found my bearings again. So I look at, this first payment, right, this 3,500 Rand is going to get to live in the investment for 59 months, right? So it's going to get to gain interest for 59 months. So so let me say contribution number 1, the 3,500 Rand is going to get to grow at an interest rate of 15% per annum compounded monthly. Okay, so that will be 15% divided by 12. Okay, so 15% is for the year, so we need to get the monthly rate, and that will be for 59 months, right? Your second contribution, okay, pretty much the same, but it's going to grow for 1 less month, right? Okay, and yeah, at this point I hope we see the pattern, right? Contribution number 3 will grow for 57 months. Okay, and all this right up until your last contribution, contribution 60, which it's not going to earn any interest, because at that point you would take the money out. So we could look at that as a 1 plus 0.15, 0 months. It's just not going to, it's not going to get a chance to pay interest. So this is a so the total value of the investment after 5 years after 5 years is going to be, this is where I really want to be completely lazy and just use the fact that I don't have to write this down on a paper. I have a computer. Right, it's going to be that contribution and how much it grew plus contribution 2 and how much it grew. Plus contribution 3 and how much it grew right, and so on until your last contribution, which doesn't get to grow, like we said. Ooh. Okay, let's try that again. Is it gonna fit? Shrink it some more. Right, okay, and it's clear to see that that is a geometric series, okay, because each term, well, depending on even what order you want to look at it as, but anyway, let's say it's a geometric series, right, where each time, well, first let's talk about what A is. So A is 3,500 times 1 plus 0.15 over 12 to the 59, right? So there's our A. Some people will take this to be their A and look at the series going backwards kind of a thing. That's completely fine. In fact, probably easier to look at it that way, but anyway, I've chosen a direction and I'm sticking with it. And the R Okay, what you see is each time this guy has an exponent 1 less. So our r is 1 plus 0.15 to the 12 over 12, sorry, to the negative 1, right? So each time we're timesing by this, which then decreases the exponent by 1, okay? Right, or if you really want to look at it like formulaically, one thing about maths, ne? Don't be afraid of bombastic looking expressions. They are usually very tame, right? So we could look at term 2 divided by term 1, okay? And what is that going to give us? Well, those are going to cancel out. And then we have two powers that have the same base, so we can subtract the exponents. So that's going to be 1 plus 0.15 over 12 to the power of 58 minus 59. And of course, this guy is just negative 1. So same thing we got there. Okay, righty-do, righty-do, righty-do. And I mean, of course, someone who has just used the formulas that they were taught in school is probably done with this question by now, but anyway. Right, how many terms are there here? How many contributions are there? There are 60 of them. Okay, so now we can use our geometric series formula to figure out what is the sum of the contributions and the interest that they earn. So S60, okay, well, let's start with the whole formula. We're going to write it nice and big so that we have lots of space. Okay, right, so that's the formula for geometric series. Now let's fill in what we know. So we want S60. We know that term 1 is 3,500 times 1 plus 0.15 over 12 to the power of 59. Oopsie. Okay, and our R is 1 plus 0.15 to the 12 to the negative 1. Right, and that is being raised. You know, it'll actually be easier if I just do this instead. So I'm going to cut again, duplicate. No, I don't want the whole thing. Let's try that again. Okay, so that is our A. I'm going to shrink it. Okay, we left behind the top of the 5. Okay, and then our R is this. Okay, right, and that is being raised to the power of n, which is 60. Right, okay, cool, and then in the denominator we have r minus 1, which is just this guy again. Okay, right, so this is something that we can just now go ahead and punch into our calculator. Hopefully it does not freak out. Okay, ooh. Okay, let me start typing here. could have just times those powers and just written negative 60, spared ourselves a bracket, an extra bracket. But anyway. Another useful thing we could do is store each of these numbers and then, you know, actually that's what I'm going to do because that's a lot less hairy. After all of that typing, I was pretty much at the finishing line and then I chickened out. Okay, so our first term is that, and we're going to store it. Let's store it in A. Yeah, there's a lot going on here, eh? Right, and then our R, 1 plus 0.15 divided by 12 to the power of negative 1. Right, so let's store that. Cool. Did I store my first one? No, I'm getting worried. So let's just see what is A. Okay, A is that, and then B is R. Okay, so now let's put it into the formula. So first we're going to say A times B, which is our R, to the power of N, which is 60. This calculator gets a bit hairy sometimes. I don't like it. Huh? It took away my whole thing. I'm sorry. Jeez. Such a tyrant. A times R, which is inside here, to the 60 minus 1, and then in the bottom R minus 1. Doesn't that look so much better? Okay, so that gives us around 310,010 rand, comma 78. So that's what the first investment will give us, and it's okay for us to move on with this rounded figure because technically the investment is not going to give us 310,010 rand. Oof, what a weird number to say. And 77,77. It's not going to give us that, right? It's going to give us the 310,010 rand and 78 cents, and that's what we're going to take. And then we're going to get another money from investment number 2, and those are the numbers we'd add together, not the unrounded ones. Okay, anyway, that was a long justification for something that maybe isn't that deep. Right, so that was our first investment. I'm going to move everything down so that we can look at the second investment. I really hope the silences aren't as awkward for you as they are for me. I feel terribly awkward, and I don't know what to do without incurring more work for myself. I.e., I do not want to ever have to feel like I have to edit these videos. That would pain me so much. I think it would slow down the rate of my output significantly. So I don't want to go there. Anyway, that's a very tangential rant. And I am failing at a very simple task, which is so annoying. Oh, there's a bracket that departed. Dearly beloved. Okay, cool potato. So that's investment 1 out of the way. Right, And maybe let's just store this number so that we can use it once we have investment two's figures. Okay, so investment one yielded this much. Okay, and now for investment two, where there's a bit of salsa. You make a deposit of 24,000 Rand immediately. So this is also a timeline of 5 years. So at T0, you immediately put in 24,000 Rand, and then you only make a second deposit of 7,000 Rand into the same account at the end of the third year. Okay, so somewhere here at the end of the third year. So so let's say T4 is here, right? Somewhere here, right, is where you add another 7,000 Rand, 7K to be consistent with my nomenclature. So end of T3, just in case I goldfish and forget what I'm trying to show here. Okay, right. Well, okay, no, I'm being dramatic for no reason. Okay, sorry, that is not correct. Okay, because, yeah, each of the T's indicate the end of, right? So T1 is the end of the first year, and T2 is the end of the second year. So T3 is also then the end of the third year, and that is where we add 7K. Okay, right. So now, right, and now we're counting in years instead of in months. Anyway, so interest on this investment is 20% per annum. Okay. Compounded quarterly. Oh, okay, cool. So if you come back, okay, so we need to work out how much this investment is going to yield. So again, we're going to look at, well, how much does this 24,000 Rand grow? So it gets a full 5 years to grow, whereas the 7K only gets 2 years to grow. Okay, so let's see then. So the 24,000 Rand is going to get to grow at 0.2 divided by 4 quarters in a year, for the full 5 years. So that's going to be 20 quarters. And then the 7,000 Rand will get to grow also at this same interest rate, but now only for 2 years. So, and that'll be 2 times 4 quarters. Okay, so this is also something that we can just put into our calci. So yeah, this one isn't too hairy, so I'm just going to do it all in one go. Nah, 4 times 5, I know what that is. Okay, and then the second term, or the second chunk of the investment. This is me desperately trying to move the calculator to the side. Okay. Right, I just love how this calculator is so committed to common fractions. Right, so that investment would be 74,000 Rand, 74,021 Rand, 33 cents. Okay, that's approximation. Okay, so we know that this is what it will yield. All right, and so the value of, okay, I need to highlight that this is investment 2. Okay, so the value of the investment, well, the complete portfolio, rather, let's say that, will have a value of portfolio of investments. Sounds so formal, doesn't it? Love it. Love it for us, having a portfolio of investments. Right. Okay, which comes to I think this is the only area in mathematics where you can work, where you can do follow-on sums with the rounded numbers, because it just makes sense in the physical world to do that. But anywhere else, always work with the unrounded figures. Okay, so store that very long number on your calculator and use that in any follow-on sums that you need to do. Okay, but anyway, we now get 384,000 rand, 384,032 rand. This is so weird to say. And 11 cents as our final answer. So, fingers crossed, squeezely. What is the value? They get the same number. Yeah. Hooray, hooray. Okay, great. Okay, I see there's a part B to this. So, let me get that in here. Is the part B linked? Let me just make sure. Oh, no, it's not linked. Okay. See you for part B in a different video some other time.